volumes, which we started last time by cylindrical shells. And let's see what that means. You gentlemen are following me? Can you see my screen?
No.
No.
Not yet.
No.
Well, let me know if you can see it.
Yes, we can
We
now.
can see.
All right, good. So, so this is the old method of calculating volumes. You have a function here, and what you do is that you want to rotate this about the x-axis. So you take a strip that is perpendicular to the axis of rotation, and I repeat, perpendicular to the axis of rotation. And then what this does is that it creates this disk actually, right? And so this disk, and you want to calculate the volume of that disk, which is one of these guys here, right? And then that's it. If you're able to calculate the volume of one disk, which is actually pi r squared, this is a disk, so it's just this area here, which is pi r squared, and then the thickness of that, which is okay, let's just put it as the thickness. It doesn't really matter if it's a dx or dy. It depends on the orientation of that. And the reason for that is actually the situation is like you're taking so many of these samples. You take a sample and rotate, take another sample and rotate, take another sample and rotate, etc. So by rotating all of these, you're going to get your object, which is depicted here, right? So you see that this edge is not really smooth, and to make it smooth, you need to make as many disks as you can. Yes, and by taking as many disks as you can, you actually asking for the limit of the Riemann sum, basically. So that delta, this width here, becomes really very, very small. Yes, and that's exactly what a dx or dy are. And that's why we put an integral. Integral means that I will just add this to that, to that, to that, to that, to that, to that, and so forth. Yes. So this was the idea of calculating volumes by cylindrical disks. Yes. Of course, if you have two functions, you may end up with something called a washer. It's more or less the same thing. So like this is a function and this is another function. If you want to rotate that, so you take a sample, but this sample is not going to go all the way down. So can you please mute your mics, Sean? Gentlemen, mute your mics, please. So if you want to rotate that, so this edge is going to rotate like this, but this edge is going to rotate something like this. Of course, it's a little bit long. So, and this is actually the thickness of that. So you get what we call a washer. So again, it's a disk, and there's another disk that is taken off from it. So it's pi r2 squared multiplied by the thickness minus the inside disk, which is gone, yes, times the all thickness, yes, and that's it, yes. And then you put an integral sign. You see what the thickness is, and you see what your r is. You just have to look at the graph and see which one is your r. For example, in this case, this will be your r1, and this is going to be your r2, for example. Yeah. So you just watch. It's not a matter of remembering anything. All what you need to do is just remember the volume of a disk, and the volume of a disk is nothing but pi r squared multiplied by the thickness. Yes. That's it. That's it. And this constitutes the area. Right. So there's nothing really to remember here except this little simple formula, which is actually the volume of a small cylinder that has a thickness of t, for example. Right. Well, what we're saying is that the basic idea here is just like if you have a function, you take a sample that is perpendicular to the axis of rotation. This is very serious, yes? All right, there's another way of doing this. It's just like instead of taking a sample that is perpendicular, let's say that I'm interested in this region here. Let's say, just make it a little larger. And I have this region. and I would like to find the volume if I rotate this about the y-axis. Yes, right. Let's say. So you could do it by the previous method, like you just have a sample that is perpendicular to the axis of rotation, and then you will end up with a washer, etc., and the rest of the story. Yes, that we already know this. But there's another way of doing this: is that you take a sample that is parallel to the axis of rotation. And if you take a sample that is parallel to the axis of rotation now, and you try now to rotate that, you see that what will happen, and this is going to come exactly on the other side here, right? And if it rotates, it shall make this funny object, which is like a paper rolled, as I showed you last time. If you take a piece of paper and roll it around, right? So this is going to come in this shape actually. Remember, the basic idea is that this is very small, just like your paper thin. And if you do that, if you look at this graph here, so these are the ones. This is the sample. Let me just use a different color. This is the sample. Of course, this is, and you want to rotate this about the y-axis. Here's another sample. Rotate this about the y-axis, and it shall make that shell. We call it a shell. Yes. So this is the official name for that. It's a shell, and this is going to make a shell, etc. So if you can cover the whole area and rotate, yes, about the y-axis, yes, and therefore you shall get you'll get these shells, and the combination of all these shells is actually going to give you the volume. So yeah. So if you just combine these, right? You take as many as you can, and you rotate them. If you are able to calculate the volume of one of them, all what you need to do is just add the volumes of each of these together. Yes. All right, that's all. Do you understand the idea here? Is the idea clear, Yasham?
Yes, clear.
Okay, so again, just very similar to the previous methodology. What we need is that we need to find the volume of one of these samples. And again, the word is very important. You see that you just take a sample, yes, a sample, a typical one, yes. And if you're able to calculate the volume of that, all what you need to do is just repeat yourself. And repeat means what? Means
Repeat
repetition
what?
means exactly that's what it is. You just have to add them up, and adding them up, if they are infinitesimally small, very small, means you're actually going from the sum to integration. So what is the difference between a sum and integral? Is the limit. Yes, they become really very small. So we have a symbol for that. All right. Okay. Good. So let's just calculate the volume of that. And last time we did an exercise. Let's say, okay, the volume of this fellow, which I refer to as dV, because this is extremely thin. You must understand that this wall here is very small. Yes, it's a very thin wall. This is the basic idea, and the volume of that, as we saw last time, was actually it's just like the circumference 2 pi r h. Yes, 2 pi r is a circumference. Sorry. And then we multiply this by delta R, which is the wall thickness. So what happens? The circumference, of course, this is exaggerated. The thickness is much smaller than that. And if you take this R in the middle, all right, and you understand that if this is your R1 and this is your R2, then R1 is approximately the same as R2. They are extremely close to each other. Yes, so think about, for example, from the university to Al Khobar downtown. This is R1, and from the university to Khobar downtown plus 5 centimeters. All right. So the first R is going to be like 5 kilometers. The second one is going to be 5 kilometers plus 1 centimeter. So there's no difference. So R1 is extremely small, extremely close to R2. And therefore, when we talk about this dr, you're actually talking about that 1 centimeter compared to 5 kilometers, which is huge actually. So the ratio is extremely small. So this is your delta R. All right. So if you do this 2 pi r, actually you're calculating what? So again, let me just sketch that. Okay. So actually you're calculating this circumference. This is 2 pi r, isn't it, Shabab? Because this is supposed to be circular, yes, not like an egg shaped like the one I've drawn. Okay, and if you multiply it by delta r, what happens to that? You will get what, Shabab?
Volume.
You'll get this area, yes. You'll get a circumference times the dimension is a square, yes. So it's a 2 pi r. So this r is in meters, and delta r is in meters. So the dimension is meter squared, correct? Yes or no? Yeah. So you're supposed to get you're supposed to get this area, the area of this strip on top. Yes, this area. Yes. Okay. And this you get by this 2 pi r times delta r. Now, if you multiply that by the height, you're actually repeating these strips basically. So you'll get what? You'll get the volume of this film. Yes.
Doctor, I think we should also multiply by the height, maybe.
Yes, this is what I've just said. See, this is the
Okay.
height. Yeah. And if you multiply that by height, you should get the volume of that. So now again, the only missing thing is just h here. So that's it. Yeah. So the volume, if I just may now clean up, right? So the volume of this fellow here is just like 2 pi r h times the delta r. Yes. And you understand this formula very well. Yes. Okay. So let me just put that. So the dv of this is 2 pi r h, let's say dr or delta r. Doesn't really matter. Yes. Okay. Just put this. Okay. In other words, you can think of this as 2 pi the radius. Okay, multiplied by the thickness multiplied by the height. That's it. Where the thickness is delta r, and this is h. Right. That's it. Okay, adding them up should do the problem. Okay, here's an example. But the most important thing is that your sample should be what? Perpendicular or parallel to the axis of rotation?
Parallel.
It should be parallel in this case. Okay, so now here's the first example. I am not really sure if I did an example, but anyway, if I did, we'll just repeat it. Yes. So x is the square root of y, which is actually, this is a function, the original function, but we don't need all of that because x is just positive. It's not negative, if you wish. Yes. So this is the part of that. Otherwise, this is equivalent to y is equal to x squared. This is the same, except that x will not be negative because it's a positive square root of y. Yes. So it's just the right part of this parabola. Okay. And this is x equals 0, and x equals 0 is the y-axis. So this is the y-axis. All right. And y equal 1, right? And y equal 1 is just this. So this is 1. So we're talking about this area. So this is the bounded area. And you want to rotate this about the x-axis. Do you understand the problem, Asham? Okay, so we'll just delete this rough draft and we will do it decently now. Okay, so this is the graph. Okay, so this y is equal to 1. Okay, and x equals 0 is the axis, and this is exactly the region. So the region is this. This is my region. Okay, right. Well, obviously now this is the axis of rotation. Okay, so my strip is going to be parallel to that. So I will take a sample. And I will rotate that sample. So this sample comes here. Let's say the you agree, Ashraf?
Yes.
Okay, so this goes something like this. Okay, Ashraf? So what we need is to calculate the volume of this. Now, please note that these samples, okay, this is really very, very important to understand that these samples will start from where to where. If I am to take the first sample, where would I take the first sample, Hashem? I would take it here, correct? And this is my second sample, the third sample, the fourth sample, etc. Correct? And then rotate. So the samples are taken before the rotation, yes? Do you agree with me, Hashem? One should
Yes.
not say that this is going to go from -1 to +1. It should go from 0 only, because this is where you get the sample. The other part of the graph is just taken by the rotation, not by the sampling. So the sampling is actually taken from 0 to 1. Do you understand the sampling? The domain of the sampling, or the range of the sampling, if you wish. Yes, Shama? So these samples are going to flow from 0y until what?
1.
Until 1y. This is very important. Okay, now I need to do is just calculate the volume of that cylindrical shell. So the volume of that, and let me just put it as dV. Okay. I say it's a 2 pi r, okay, the thickness multiplied by the height. This is my formula. Okay, so now dV is what? Is a 2 pi. Let's look at the radius. Isn't this the radius? Yes or no?
Yes.
Is it a
Yes.
vertical? Is it a vertical direction or a horizontal direction?
Vertical.
So
Vertical.
it is measured from where? From the
From 0.
x-axis
I took to
until
hypotenuse.
yes, until yeah, from the x-axis until you hit the function, correct? So it is obviously equal to y of the function, isn't it?
Yes.
Yes.
It is the y the function because it goes from the x-axis until you hit the function. So if you go vertically and you hit a function from the x-axis, that is your y of the function. All right. Okay. So this is r. What about the thickness now? What is this thickness here?
dy.
It's a dy. So this is my thickness. What is this height? Okay, let's just look at this height. The height is this. Isn't this the height? Isn't this the height, Shabam?
Yes, it is.
Okay, so what is it? You are measuring this from where?
X of the function.
From the y-axis?
Yes.
Correct. Until you hit what? Until you hit what?
The function.
The function. So this is equal to x of the function, isn't it? So this is just like x. All right. In order to find the volume, what do you need to do? Add all these up, yes? So the total volume is equal to what now? So the total volume is the integral, okay, of 2 pi y x dy. You agree, Asham?
Yes.
Okay, and the samples are going from where? You are integrating with respect to what now? With respect to y. So you should go go along y, and the samples are taken from y equals 0, as we have just discussed, to y equal 1. We're done, except one thing, except this fellow here. I don't know what this fellow is doing here. Sorry, the other fellow. This is what? This is x. And we integrated with respect to y, so that must disappear. How does it disappear? Because this is x of the function, yes? Do you agree with me that this is x of the function, yes?
Yes.
Then this must be equal to what? 0 to 1. And we have 2 pi y, and x of the function is what? Is the square root of y. And we are done. That's it. It's as simple as that. You get 4 pi over 4. I will not do integrations. Yes, this is not the objective of this session. Does that make sense to you, Yashabam? See,
Yes.
what are the common mistakes that a student would do? Is he like, okay, fine. The first common mistake is say, okay, fine, is that he will integrate from -1 to +1. Right? You do not do that. See why? Because you should look at your samples. I am not going to take a sample from here and rotate. I will take a sample here and rotate, sample here and rotate, sample here and rotate, sample. So what is the extent of samples? They go from here up to here. This is the domain of the sample, yes? I mean, you just go, you don't go beyond that. See, it's useless, right? This is a very, very common mistake, right? And the second common mistake is that you actually don't know what's going on. You try and subtract functions, add functions, etc. What I'm saying, Ashraf, is the story is extremely simple. This is the formula you need to know. Right? It's 2 pi r thickness times h. And then look at, just get only one sample and look at it, have all the details there. See if you're integrating with respect to x. So everything must go into x. If you integrate with respect to y, then everything must go into y. And then you're done. That's it. Okay, here's the second one. I hope everybody's happy with this session.
Doctor,
Yeah.
in KF beam old exams, the cylindrical shell, it's always work with problems from majors and finals, or I need to try all the ways to find the exact one.
You have a good question, a very good question, and you have a very bad question. Let me start with the bad one. The bad one is that I am not really very much concerned about the exams. We're here to understand what we're trying to do here, and you will need all these integrals, right? Volumes in your engineering courses. Trust me. And I was an engineer once. I have a doctorate degree in engineering, by the way. If you don't know, that's now you know. So you will need all this stuff. See, and this is one of the most fundamental courses. Let's just try and start this course away from exams. If you just do any messy work in exam and you still understand, you should be happy with yourself. Second thing, which will not happen, see that if you understand the course, you'll perform extremely well in exams. The second thing is that you have an excellent question, which is, you see, which method do we use? Do we use the cylindrical shell or the disk? You see, there will be problems that you can do by the cylindrical shell, and they will be better suited for that. And there will be problems that you do by the other method. You see, that depends on the problem. And then how do you decide if this problem is better done by this method or that method? That all depends on your experience, yes? And I mean, you just don't look at a problem and say, okay, I'm going to use that. You see, your experience should tell you. And I'm going to give you an example that you will decide that the cylindrical shell is better, and you'll see why shortly. But I like the question because this is fundamental for the coming problem. I was going to mention this anyway, but here is the problem. See, what I want to do is that I want to calculate that. And are you okay, Abni? Okay, just listen to this exercise, and if you still want to ask the same question, please do. Is the region bounded by this, and I want to rotate this about the y-axis. Yes.
I have a question about the first.
Yeah. Yes. Here.
Yeah. So we take the small circle for the r, small r, inside.
Yeah. You see, you look at this. This is the shell, correct? And this is your r, isn't it?
Yeah, but we have two.
Oh yes. This is what we said. Now this is the shell actually, and the other one is if you look here, the other one is exactly here.
So it doesn't.
It doesn't really matter. This is what we just been saying. That they will be extremely close. Look at them. You cannot even see them. And the best way to see this is that you roll a paper. You have a piece of paper now in front of you. Just make a cylinder out of it and look at the outer and the inner radius. Will be almost the same.
Yeah.
So it doesn't really matter which one. Yes. In the limit, they will just come close to each other. Okay. So let's just have a look at this example. All right. And this is a parabola, and if you want to spend time plotting this parabola, anyway, if y is equal to 0, then x is 0 and 2, yes? So this is 0 and 2, right? And this parabola opens up or down, Ashok?
Down.
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 So this looks like this, correct? And it has a maximum at 1. Why does it have a maximum at 1? Because y prime is equal to 2 minus 2x. If you equate it to 0, then x is 1, so? But the maximum is at 1, correct, Ashok? Again, this is Math 101, yes? So again, I assume that anybody can sketch this parabola. And we're doing, again, you do a rough sketch first. So this is the parabola, and y equals 0 is the x-axis, yes? So it's between this and this. So where is that region? It's this region. And you want to rotate this about the y-axis. So that's the problem. Okay, now since we understand this, let's just clean up and do a decent graph now. Okay, all right. So here, okay. So this is 2, that's a 0, and this is 1. And if x is 1, then this is also 1, y is 1. Okay, so that's the region. Now, all what you need to do is just rotate this about the y-axis. Of course, this will be like sort of a mountain, right, that rotates. So things are going to be hollow, yes? Like in essence, this is going to look like this. And if this rotates, this comes as such, yes, basically. So this is going to be filled, like this is all the way up, yes? If you look from the top, then this is circular. This is going to go around, yes? And there will be nothing here, but this is all filled, yes? So if you rotate that, yes. You know, I hope I can use mention, but I don't have time for it today, but we can show you a picture of it later, right? Okay, so what you want to do is that you want to find the volume. So the region is this region. This is the region. And you want to rotate this about the y-axis. So you take a sample, as always. And the sample should be what, Shabab? Perpendicular or parallel to the
Parallel of the shell cylinder.
exactly.
Depends on the method.
Exactly. We're doing this by cylindrical shell, yes? Right? Okay. And I will show you that what's the difficulty with doing this by the desk washer method. Okay, let's just do it by the easy method first, yes? Okay. Now if you rotate this, this comes here. Okay. Okay, so this is around, okay? So let's calculate the volume of this shell. Okay, so what is the volume? It's 2 pi r thickness times h, correct, Ashok? Yes?
Yes.
So dV is what? The small volume is 2 pi r. Let's see r. Where is r? R is this. This is my r. You agree, Ashok? Which looks like what? The distance from the y-axis until you hit what? Until you hit the curve, yes?
The x of the function.
So
Yeah.
it is x of the curve, yes? Or let's say the function. Okay. And then multiply by the thickness. What is this thickness here?
Delta X.
Delta X.
or
Yes,
Tx.
very, very good. And now this is the height. This is your h, which looks like something that starts from where? From the x-axis until you hit the function, which is what?
Y
It's
function.
y of the function. That's it. Are we integrating with respect to x or y?
To
X.
X.
X. So what is y of the function? It's 2x minus x squared, correct? So now dv is going to be 2 pi x and 2x minus x squared, and this is a dx. So the volume is going to go like the integral 2 pi x 2x minus x squared dx, and then the samples The samples are going to go from where to where, Rachel? Where is the
From
first
0
sample?
to
0
2.
to 2.
Yeah, so these are the samples, correct? Right, so this is from 0 to, not from -2 to 2, from 0 to 2. We're done. Okay, this is supposed to be 8 pi over 3. Okay, back to your friend's question. You see, what happens if we do it by the disk method? Yeah, is everybody happy with this? That's very simple. Yes. Okay, now let's just see what happens if we do it by the disk. So this is 2, and you take this sample that is perpendicular to the axis of rotation and rotate it. Yes. So if you rotate it here, this is going to come here. Okay, so that's your. All right. Oh. Something like this. Okay. Now let's just calculate this. Okay. Now this is going to be pi r2 squared. Yes. Times the thickness. Yes. Minus pi r1 squared multiplied by the thickness. Yes. T. Isn't it, Tasha?
Yes, that's good.
Okay. All right. So let's just see. So this is my dV. Yes. Okay. Let's just put this together. So this is pi. Okay. R2. Now let's look at R2. What is R2 here? R2 is this. It's x of the function, isn't it?
Yes, it is.
Okay. And what is the thickness, by the way? The thickness is dy, isn't it? You agree?
Yes.
Yes.
Okay. So it's x of the function squared minus, what is R1?
Small x.
The smaller radius.
It's also x of the function, isn't it? It hits the function. So x is a function squared. But this is only the left part because the function is doing this, is doing that, and then doing this. Correct? And then I'm going to this, and on the second choice, I'm going to this side. That's R2. So I should split x. You see, this x is not the same as x, isn't it? In terms of y, yes? So what is the story here? Now y is equal to what? 2x minus x squared, yes? So therefore, I need to replace everything for y, correct? What I show. So I need to complete the square here. So I say, okay, y is equal to minus x squared minus 2x plus 1 minus 1, correct? So y is going to go like minus x minus 1 squared plus 1, okay? And now you take this x minus 1 on the other side. So this is going to be 1 minus y, all right? And then x minus 1 is going to be plus or minus y, 1 minus y. So x is going to be 1 plus or minus 1 minus y. Do you agree with me, Yashwan?
Under
Do
the
you
root.
mean the root?
Yeah, under the square root, yes, of course, yes. Okay. So you take one with a positive side. So this x is going to be like x is going to be 1 plus the square root of 1 minus y. And this x is going to be 1 minus 1 minus y. That's very important. They're not the same x, yes? And then you go and replace them here. All right. And then you'll do your integration with a lot of square roots, basically. Do you understand why now the method? Because we had to split the function. Now, if this function was not so simple, was not this, for example, it was really very complicated that you cannot solve for x. If this had an x cubed, for example, like y was 3x squared minus x cubed plus x5 plus 1, how can you solve for x here? You cannot solve for x. Then what you should do is that this problem is best done by what, Tashabam?
Cylindrical shell.
Exactly. You see, now if you want to do it by the disk washer method, then you know what you will see. And it doesn't really happen like I know this for sure. When I look at a problem, they say, hey guys, no, I cannot do it by this method. No, what you should do is that you get your hands dirty. See, like you go and do the problem actually. And when you do the problem here and you wanted to substitute something for this, because actually you're going to integrate with respect to what here? Respect to y. So these must be exchanged. And how do you exchange them? Where do you get them from? They're not going to be go zero. I mean, the worst thing is that you say x squared minus x squared is zero, because this x is different from that x actually, because you split the function in the middle here, yes? So this is some x, and this is some other x, which are here basically. Yes.
So, Mr. In general, if it's touching the rotation axis, we use the disk method.
I don't know.
The cylinder.
I wouldn't comment as such. I say that go ahead and struggle with problems, and the best way to do it is just is again solve problems, and you will have experience. There will be no rules. For any rule that I will give you, there will be an exception, and you will have problems. But again, I'm not here also to give you some general guidelines. I'm not going to program you. See, this is not my job. See, like my job is just to make you understand this, and you program things. Yes. So when you go to and you want to do it by a machine just like me, you know exactly what's going on. And I'm not going to give you formulas. See, like I always have a shell, something like this, and I say, okay, look at the graph here, and let's just find and well, the basic formula is there, but let's just look at the dimensions from the graph. See, why should you remember all that stuff? See, there's no need to do that.
Yes.
Anyway, I trust me, it only comes by experience. You see, you have more experience, you will be far better. Okay, let's just do another one. Anyway, we're doing examples now, nothing else. The formula is just this. Do you think? Yeah. That's the whole class. Yes. The rest is how you can do that. Okay, I have this this relation, and y is going between 0 to pi, and x 0, and you want to rotate this about y equals -1. See, this problem is interesting. Okay. First of all, I need to sketch this. And how do I sketch this? Of course, there's the hard way of sketching that, and there's the easy way of it. The hard way is that you use your techniques of Math101, find the maximum, minimum, inflection point, etc., and you do it. But you can do this very quickly. Let's look at it. See, now what we say that, okay, instead of starting with x, start with y, because it looks like x is a function of y here, yes? Okay, so let's see that if y is equal to 0, what will happen to the square root?
Also
If
zero.
y is 0, so if y is 0, then x is 0. So this is our first point, correct?
Yes.
What is the maximum value of sine when the argument is pi over 2, correct?
Yes.
Yes.
One.
So if y is equal to pi over 2, what is sine pi over 2? 1. The square root of 1 is what?
1.
So that if y is equal to pi over 2, then x is going to go like what? Like 1. So this is the second point, correct? And it looks like an increasing function, because if you it goes from 0, if y is equal to 0, sine 0 is 0, and it goes up to sine pi over 2, which is 1, so it goes from 0 to 1. So it makes sense that this is going this way. Yes or no, Asham? Makes sense?
Yes.
Okay, fantastic. Now at pi, what is the sign of pi?
0.
0. Remember that we are doing points for y. So pi is y. So the sign of pi is going to be 0. So x is going to be 0. So most probably this is doing that. Not 100% sure, but it looks like this is what the sign does basically. We're only taking the square root of that. Do you agree on this?
Yes.
Okay, what is x equals 0? Is the y-axis. So we're talking about this region. And you want to rotate this about what?
Y equal -1.
Equals -1.
Y minus 1. So you want to rotate this about this axis here. So we understand the problem? Okay, now let's just delete it and then do a decent sketch. Okay, so now, right. So this is, so this is pi, obviously this is pi over 2, and this is just like 1, minus 1. Again, we like to make our mechanical engineers happy, yes? This is the center line. And this is at -1. Okay, so the rotation is about what? About y equals -1. So we take a sample, yes, Asho? Sample? We are the masters of samples, yes? That should be parallel to the axis of rotation, isn't it?
Yes.
Okay, so this is it. Okay, let's rotate it. If it rotates, it gets here. Okay. Let's see that my graph is the best one in town. I don't like it. Just make it smaller. Okay, anyway, this is not important now. Okay, here. This is your shell. You agree, Shabab? So what is the formula? 2 pi r the thickness times the height, yes? All what you need to do is just look at the measurements here. Okay, let's just do this. What is the radius? Isn't this r?
Yes.
But what is it? What is it? What is the top function?
Plus
What
1.
is the,
X
you see
plus
that?
1.
Okay, look, if you have 7 and -3 here, what's the height of that?
10.
10.
It's the top function minus the bottom function, regardless, yes? Positive, negative, I don't care. It's the top minus bottom function, correct? So that becomes a 10, all right? Okay, so I'm going to do the top function minus the bottom function. So what's the top function?
Y of the function.
So exactly, so the top function here, this is y of the function. And the bottom function is what?
-1.
-1. So what is r? Is
X
y
plus
of the function
-1.
minus, so this is +1. You agree with that?
Yes.
Okay, fine, let's just leave it. Okay, so do you agree that this is my h?
Yes.
So what is h?
X of the function.
I'm not, this is not really a function. I should be careful with the terminology.
Of the graph, I mean.
Okay, let's say, I'll just put it as f, yes? What should I say? Of the, okay, graph. Okay, good. Okay, right? Of this relation, if you wish, yes? Okay, so now I'm ready. So what is my dv? Is it 2 pi? What is r? R is y of the graph, as your friend suggested, +1. Yes? Multiply by the thickness. What is the thickness here?
dy.
dy. This is the thickness. And what is the height? Is x of the graph, yes? You agree, Shabab?
Yes.
So we are doing this integral with respect to what? With respect
To
to
y.
y. So the samples are taken from where to where?
from 0 to pi.
Exactly. You see, these are the samples, yes? Right? The samples are not from anywhere. They are exactly from that location. From the 0 until what? Until pi. So now I can tell you that the volume is from 0 until pi of 2 pi, and I have y, excuse me, plus 1 multiplied by dy multiplied by x. Of course, this x should disappear. Why? Because the integral is with respect to what? With respect to y. What is x of the graph?
X equal to root of sine.
That's it. I'm not asking you to evaluate. Do not evaluate. This is enough for me. This is a very, very tough integral. You probably cannot do it at this age. Yes. All right, Ashar. But this is what the integral is. If somebody can take 5 riyals and do it for us for the integral, we're fine with that. But this is the basic idea. Are you fine with this, Ashama? You see that?
Yeah.
You see? So this little technique of just sketching one of these shells, one of these washers, discs, etc., should save your life. See, I mean, there's nothing to remember except that little formula. I'm going to give you a chance to do this on your own. I want you to explain to me what this is. Oh, here. Y equal x squared. Y equals 0. X equal 1. X equal 2. About x equal 4. I want you to do this, Shabab, now. Okay, I'll give you like 3 minutes to set up the integral. Please do it, Shabab. Do it.
Mr. Can we see the please?
So, sorry, I was just looking into your. Okay, here, that should be done.
Thank you.
Okay. So we have what, 44 students? You guys checked in all? You guys are all awake?
Yes.
Yes.
How can you speak on behalf of the class, Shabab?
Inshallah.
Inshallah. Yeah. I hope this this time passes, inshallah, and the country will be fine again, inshallah. And if you want to, if you miss your university, let me just give you. Okay, this is your tower from my office. Yes. See that?
Yes.
Yes.
Okay. Just in case, you missed the place, tell me from time to time to show you a picture from my window.
No, I don't miss it.
Oh, you will be very proud once you graduate. I graduated from this university 500 years back. With all this bad time that you have, tough time, yes, right? And these will be some of your best memories.
Inshallah.
I'm sure, inshallah. Okay, now here's let's look at the problem. Okay, do it, please. Huh? Okay, so okay, rough sketch. Yes, this is y equals x squared, correct? Y equals 0 is the x-axis. Yes, x equal 1 is this, and x equals 2. This is 1 and this is 2. So we're talking about this region, isn't it?
Yes.
Okay, and you want to rotate this about what?
X equal to 4.
Yes, that's the axis. Yes, we know what this is. No, this is not a simple problem. Yes, Difficult, very difficult, yes? No, it's not difficult. Take a sample, you'll be fine. Okay, let's just do a decent sketch. Right, so let me just delete that. Okay, so again, let me just take this to the extreme because we don't need all of it. So this is your, this is x squared. Okay, and we're going from this is x equal 2, this is x equal 1. So actually, we do not need this, yes? That we do not need. This is exactly what we need, yes? And you want to rotate this about, this is a 3, this is 4. Okay, this is our center line. Okay, this is the axis of rotation. Okay, and let's look at this. If this rotates this point here, where should it be? At 6, isn't it? What did I show?
Yes.
So, well, actually, if this rotates, this is going to look like this. Yes, and you have only 1 point. Sorry, this is going to be like here, yes? And this is going to be at 7. So this is actually the rotation. This is how this will rotate. And think of this as rotating all over. So what do? We take what? We take what, Ashraf?
Sample.
Very good. And this sample will come and hit here. Okay, we are done. That's our beautiful sample. All what you need to do is measure things. Okay, so what's the formula? The formula says what? 2 pi r thickness times h. What is the thickness?
Thickness is
Delta
dx.
X.
Dx. So this is a dx. We're done with that. And this is my 2 pi. And I need only these, sorry, I need these two. This is my dx, yes. This is not a dx, yes. Okay. So I need this r and this h. So what is this r? Okay, let's look at the graph. Isn't this my r? Yes or no, Asham?
Yes, doctor.
And what is it from here to here?
It's 4.
4.
It's 4. And what is it from here to here?
X.
Or here to here? Which is the same as that, yes?
X of the function.
Yeah, you actually come from what? Why is it x of the function? Because you start from where? From the y-axis, and you hit the function horizontally. So this is x of the function. Okay, so now my dv, okay, dv is equal to 2 pi. Now r, what is r now? What should r be?
4 minus x of the function.
Yes, exactly, x of the function. Multiplied by what? What is h now? Let's look at h. What is h? Isn't this h?
Yes.
And
Yes.
what is it? You're starting from where?
From x of the function.
Yes, from the x-axis until you hit what? Until you hit the function vertically. So this is what?
The y.
Y of the function.
X squared. Yeah.
Yeah, so it's y of the function and multiplied by what? Multiplied by dx. Now everything must read in terms of x. The only odd thing is what? Is this fellow here, yes?
Yes.
And where do
It's
we get it from? It's y
Mm,
equals x squared. So the volume is what? Is 2 pi 4 minus x. This is x squared, this is a dx. And now let's look at the samples. The samples go from where to where, Shabab?
1 to 2.
Exactly. So this is 1 to 2. We're done. You see, these are the samples. These are the samples. And we're done. You see how simple this is. It's extremely simple if you understand this little formula. That's all. And I'm not going to work out the integrals as always. This is a very trivial integral. And Allahu Alam, where did I put the answer? The answer is this. Yes, I have it. You check my answers, Ashwam. I'm not sure if early morning was fine for me today. طيب يا شباب. Okay. Now I have 2 more exercises which are fairly simple. What I want you to do, I want you to describe the solid whose volume is given by this. I have okay, 0 to 3, and I have 2 pi x power 5 dx. So what is this? What is this solid? So the volume of which is given by this.
dx
Okay.
is
Right.
thickness.
All right. So usually what do we do here? We have 2 pi r, yes, h,
Height, thickness.
yes, times the thickness. So the thickness is obviously dx, correct?
Yes.
And this is my 2 pi. So this is my thickness, this is my 2 pi. So it means that actually that r multiplied by h is this fellow here. Right?
Yes.
yes, doctor.
Okay. Then if you have, we're trying to guess. I'm not really sure of what I'm doing here. If you have, so this rotation is about the x-axis or the y-axis, Asham?
X.
Is it x?
X-axis.
Is it? If you have the thickness as dx.
Y.
So
Y.
the thickness is dx. Yeah. So the rotation is about the y-axis or some parallel axis to it. So the rotation is about the y-axis. Okay. Let's just delete that. Okay. So it means actually, so like this is a function and we are rotating about the y-axis and we're taking a sample, something like this. All right. And if you do that, then this r is most probably going to be x of the function, isn't it? Isn't it r? If you have a function something like this, and I'm rotating that, so this is my sample, and if it rotates, it comes here, correct? Can you tell me what is r? What is r, Ashwam?
Yes, x of the
X.
function.
Yeah.
Is x of the function? So it makes sense that I will isolate that some x. All right, and I would call this the thickness, and these are my 2 pi, and I would call this the r. So this looks like what, Tashabam?
The height of the function.
It
H.
looks like the height, and this is the height, isn't it?
Yes.
So it means basically I'm trying to put together this function actually.
From
This is
0 to 3.
from 0 to 3, right? So I have an idea. I want to make sure that this idea is correct. But how did I reach this? It's just by analyzing, extracting, understanding the formula, etc. But I will want to make sure that what I've just done is correct. So this problem looks like I am rotating, right? This is 3, and this function is actually x power 4, and I'm rotating this from 0 to 3 about the y-axis. Does that make sense? Let's see. I will take a sample, and then I will rotate it. So now if I do the problem independently now, so what is it? It's a 2 pi, the thickness is a dx, and then this is x of the function, 2 pi r, x of the function, multiplied by the height, which is y of the function, and then I'll do this from 0 to 3. Then if I replace this by x to the 4, then I get the answer, correct? Yes?
Yes.
So this is correct. So the problem is actually, now if I want to summarize this problem, is the volume generated by rotating what, Shabam? By rotating y equals x to 4 from 0 to 3 about the y-axis. That's what this is, what this integral is. Does that make sense to you? You may reach something else, I don't know, but this is my primitive analysis of the problem. And how did I do it? I just compare that to that. Make sense? Yeah, Shabam? Any question with respect to that?
Later.
Okay, another one. I want you to describe the solid that has this integral. The volume is given by this 2 pi 3 minus y 1 minus y squared. This is a dy. Okay. What am I going to do? Now I'm going to say, okay, fine. This is an integral, and I have a 2 pi, fine, and I have the thickness. It's a dy. So since I'm doing a dy here, so it means that I'm just taking a sample here, and I'm rotating this about what, Tashawam?
The x-axis.
The x-axis. So the rotation is about the x-axis or something parallel to it. So it's a sleeping sample because I have this thickness. Well, the thickness is just a dy. Okay, fine. So I know this. All right, let's just delete that. So what is left for me to do? This is my thickness. So what is left is I need to find what R and H are. What are these? Okay. Can you think of something?
3 minus y is r.
So
Oh.
if you have something like this, right, and you want to rotate this about, let's say,
y equals 3.
yeah, it looks like there is a 3 minus y, 3. So if you have a function and this is a 3, and this is your y of the function, so actually this distance from here to here is a 3 minus y, isn't it? تمام يا شباب?
تمام.
So I'm trying to understand what this thing is. Yes, this is a 3 minus y. So if you have a function that is y, then actually 3 minus y is a difference between the function and 3. Yes. So this is, again, let me just say this is your function and this is your 3, right? From here to here is 3, and from here to here is your y. So actually this distance
3 minus 1.
is a 3 minus 1. Okay, so if this is the 3 minus y, okay, so this is actually your function, which is what? Which is x equal 1 minus y squared. I'm dreaming. I could be wrong. I think, yes. Okay, so this problem looks like I am rotating this function or this relationship. So this relationship looks like what, Tasha? So what is it? What is this? This is, again, I lost my colors. Let me get my colors back. Of course, you're surprised at the way that I do it to see that this comes out of experience. Now I'm saying, okay, maybe this is what the situation is. If it turns out to be wrong, then I'm wrong. So, so this is x equal 1 minus y squared, which is this sleeping parabola, which has a vertex at what here? At 1, opens to the left, correct?
Yes,
Yes.
correct.
And I'm rotating this about this line, y equals 3. It looks like that. Okay, let's do it. Let's see if this is true. Let's make sure that I might be wrong. If I'm wrong, then there's no problem with that. So this then the y is going to go from 0 to 1, because this is what the integral is. Let me just write the integral again. This is 0 to 1 of 2 pi 3 minus y multiplied by 1 minus y squared dy. Again, this is not a simple problem. I'm not trying to deceive you. Say, okay, fine. You look at it and say, you know what's happening. This takes a bit of a trial. You see, am I rotating about the y-axis? Am I rotating with the x-axis? Is it the same axis or some shifted axis, etc.? So this is the graph of the function or the relation. So this is 1, and this is also 1. So this is actually x equal 1 minus y squared. And I'm rotating this. This is, I need more space than this. Okay, let me just delete that. I need more space, which means let me just, okay, this is 1 and this is 1. So this is x equal 1 minus y squared. And I'm deleting this is 2 and this is a 3. So I'm rotating this about this line. Okay, so if I rotate this about this line, so this is 1, 2. This is 2, this is a 3, so it becomes 4. This is 5. Okay, so this has to come here, and it goes like that. So this rotates. It will go like this. Yeah, not the best one, but you know, you can improve that. Okay, so this is how it will rotate. Okay, let's take a sample. And if this sample rotates, then it should go like that. Okay, let's calculate now our stuff. Okay, I have 2 pi. What is the radius now? Let's look at the radius. This is my radius. Isn't it, Shabab? And
Yes.
from here to here is what? Is y of the graph, yes? All right.
Yes.
And from here to here is what?
3.
Is a 3. So now, so what is r actually?
3 minus.
Is a 3 minus y of the graph, yes? What is h? Is actually x of the graph. Nothing else, yes?
Yes.
And now what is the thickness here?
dy.
dy. And you're going with the samples from where to where? Where are the samples?
From 0
Correct?
to 1.
Very good. The only thing that I have to do is what?
Change x to y.
Yeah, sorry, not this one, yes. Change x to y, yes. So this is going from 0 to 1, 2 pi, 3 minus y, and x of the graph is actually this, yes. Where is that?
It's down.
Down here.
Yeah.
Did I lose it?
The
Oh,
orange one.
X. Yes.
Yeah.
1 minus y squared. Is this the same integral that was given to us?
Yes.
Yes.
Yeah. So this is a little complicated problem, but now with a little analysis and little patience also, we know that this is the rotation of that region, x equal 1 minus y squared from y 0 to 1 about y equals 3. Okay. There's no better way to do this, except you have to be patient, try your luck, and maybe you're successful. I have one example for you to do, probably here or home.
Mister,
Try. Yes, sir.
the 0 to 1 interval, do we take the x or the y?
No, this is the y, yes?
Yeah,
With
so
respect to y. So this, you're going from here. So these are the samples. Correct? So you will collect them up, yes?
yeah,
From this level to this level.
okay, thank you.
Okay, so one more. Again, describe the solid. I would like you to do these two home measurement. 0 to 2, y over 1 plus y squared dy, and also this 0 to pi over 4 2 pi minus x cosine x minus sine x. And please just do not drop the measurement. So I would like you to work on these two, so you really understand the formula, that dv. If you can do them, you understand them, you should be confident that you are very fine with this section. Have a nice day. I will terminate the class here. Okay. I will not do these two problems. I'll leave them for you. I do them, then I will spoil them for you.
Doctor,
Yes, sir.
these two problems, should we describe what is the graph?
Exactly the same problem. See, now this is a volume that is given by this formula. So what is going on? So describe this. So what is this? It's a graph of this rotated about this axis from this level to that level.
Okay.
This is what you should say. Shouldn't be difficult after I've solved these two problems for you. Have a nice day, Sean.
يعطيك العافية.